Okay, on the previous slide, you looked through a worked example of how to simplify when you have a square root of a negative and using I to do so. So these are just a few examples in a way where I can walk you through and explain it as we go. So the biggest thing to know when you have the square root of a negative is you can pull an I out of that square root. The rest of the simplification works like normal problems. So for example, the square root of -4, essentially what I am doing, and you don't have to show this every time, is I'm separating out the -4 to show that it is -1 times normal 4. Well, then with radicals, you can split them up. And then what we've been learning about today, the square root of -1 is equal to I. So this turns into I root 4. So now, this whole part up here, you do not need to show this every time you do these problems. The big idea is when you see that square root of a negative, so example, the square root of -12, I see that square root of a negative, I know that means I pull an I out front, and it turns into I root 12. So now we can finish simplifying these. The square root of 4 is a perfect square. That equals 2. So essentially we have I times 2. And then just to make it look like normal math terms where it's the number first, then the variable, we'll turn this into 2I. So square root of -4 simplifies down to 2I. Now, the next one, square root of -12, we already pulled the I out. That part's done. Now it's just a normal simplifying problem where square root of square root of 12 is not a perfect square, but it can simplify because we can break it down to be, let's say, 2 times 6, and that breaks down to be 2 times 3. And then just like we've done in the past, we look for our pairs. There's a pair of 2's we can pull out. So the 2 comes out front, the I is still out front, and the 3 stays inside. So no, simplification is the same as it's been in the past. There's just an I in there now. This next one, 5 plus square root of -50. It does not matter that there's now that addition or subtraction in front of it. The big change, we see that -50. We can pull the I out front and make it I root 50. So it just turns into a coefficient of that square root. And now from here, again, square root of 50 is not a perfect square. However, it can simplify. We can do 2 times 25, which turns into 5 times 5. Again, you look for the pairs. Any pairs come out front. Anything extra that we have not split up stays inside. So this turns into 5 plus, then the 5 came out front, 5I root 2. So it just makes it look a little bit longer. Last one, you notice these are kind of building up one extra piece at a time. This last one here looks more like a quadratic formula, say. So that's why we have this one in here. Okay, so first step here, just like all the others, we see that negative under the square root, so that means we can pull out an I, and then it turns into a positive 8 under the square root. So now from here, if we couldn't simplify that 8, we could be done, but we can simplify that square root of 8. It can turn into 2 times 4, which is 2 times 2. So we can pull a pair of 2's out. So this turns into 6 minus 2I. There's still 1 2 left inside, all over 2. And then the next part of simplifying that we have just recently talked about is how we can split this fraction up so it can simplify a little more. So this can split up to be 6 over 2 minus 2I root 2 over 2. Essentially, we're taking that common denominator and just putting it over both terms separately. Because what that lets us do, 6 divided by 2 is 3. And then over here, those 2's cancel out to be 1, so it turns into I root 12, root 2. So, and that is the full simplification. Again, I know that especially that last one gets a little tricky with the fractions, so I don't want that to throw you. The big goal here is that we understand that when we have a negative under the square root, it comes out and turns into an I. So let me know if you have any questions. We're going to keep working on these simplifications and getting used to having I in our problems now.